So this video is designed to help you with lesson 8.8 in the algebra book, particularly questions like number 34, it's on the board, that have more than one variable. That's sometimes confusing to students, so I want to do a couple of those to help you out. So if you look at this problem right here, 10p squared minus 5pq minus 180q squared, it fits the form of ax squared plus bx plus c, except that now you've got some extra variables. So normally we wouldn't have a q here or a q here. So think about doing this problem just with the p variable, and then we just kind of add the q in later. That might help a little bit. But we do the numbers the same way. So the first thing I want to look at is, are there any greatest common factors I can pull out? I want to do that before I start factoring into smaller pieces any trinomial or polynomial. So in this one, I noticed right away that I can pull a 5 out of each of these terms. So we're going to go ahead and factor that out. We'll get a 5. There's nothing else in common. There's no p for every term or no q for every term. You also want to look for that, but I just got a 5. So I end up with 2p squared minus pq minus 36 q squared. Okay, and so for now we just want to leave this 5 kind of hanging out there by itself. And we're going to factor this factor. Remember, there's two factors here. One factor is 5, and one factor is this trinomial. But we're going to break this trinomial down into smaller factors called binomials. And when we do that, I want to think of a couple of things here. So I have a little thought bubble over here, and I'm thinking one thing is that I want to know what 2 times negative 36 is, which is going to be negative 72. Okay, and I'm remembering that when I factor this out in FOIL, my last term has to be negative. So that means I'm going to have a positive and a negative, because that's the only way to multiply and get a negative. And then my middle term is going to be negative, so I'm going to want a little bit, just like one more negative than positive. So my factors have to be pretty close together. That actually helps me out with negative 72, because I know that 72 has factors of 9 and 8. One of those has to be positive, and one of those has to be negative. And since I want one more negative than positive, I'm going to make the 9 negative and the 8 positive. So without having to list all the factors of the product of 2 and negative 36, I was able to come up with the ones I wanted. Now, if you can't do that right away, it's okay just to list all those factors, and eventually you'll find it. But 72 has quite a few factors, so I was able to save myself some time. So now, if you remember from our lesson, when we have a coefficient of the first variable, or the variable that's other than 1, greater than 1, we're going to have to do what we call grouping. We're going to break this into 2 parts. So I'll show you that right here. We're going to make negative 1, and there is a 1 there, you just can't see it because any variable has a 1 coefficient if there's nothing there. So there's a negative 1 here. I'm going to break this into those 2 parts, and the parts are right over here. I've got a 9 and an 8, and I want to know where each one goes. So I'm going to put the 8 with the 2p, because that makes sense to me. So I'm going to write this as 2p squared plus 8p q's. Okay, and then I have a negative 9pq and a negative 36q squared. So you see, all I really did there was I changed this negative 1pq into 8pq's and negative 9pq's, and together that makes negative 1pq. So maybe I should put these little arrows more like that for you. Okay, so the next thing we're going to do is we're going to group those together. So after I've grouped them together, what I want to do is I pull out the greatest common factor of each of these binomials. So this one is going to be a 2. 2 goes into 2 and 8, and a p, because there's a p here and a p here. And so that gives me a p there. 2p times p gives me 2p squared plus 4q. Just check that out. 2p times 4q should give me 8pq's. Okay? Then over here, we pull out a negative number. Since I have a negative in both terms, I want to pull out a negative 9. That's the biggest number I can pull out, a 9 and 36. And I can also pull out a q. And what that's going to leave me with is a p here. Negative 9q times p is negative 9pq. And over here, it's going to give me a negative times a positive gives me a negative 4q. 4 times 9 is 36. Q times 2q is q squared. Now, like before, you'll remember that we next look for a common factor. So one of our factors is p plus 4q. So I'm going to write that right here. P plus 4q is one of my factors. Now my other factor is what's left after I factor that out. So I have 2p minus or plus negative 9q. Now, you're almost done here, but you can't forget this 5. And that's what students often do, is they forget that 5 that we factored out a long time ago. That greatest common factor of the whole thing has to be brought down. And again, if you want to verify that you're doing it right, all you have to do is FOIL these two terms and then multiply everything there by 5, distribute that 5, and see if it comes up with our original polynomial. This next example is question 43, which often gives students a little bit of trouble, so I thought I'd do that for you. And what you notice right away about this problem is it has a lot of variables with higher exponents than 2. So you have g to the 5th, for example, g to the 3rd times h, and so on. The other thing you notice is that it has 4 terms. And that clues us in right away, whenever it doesn't have 3 terms, that you definitely want to start grouping this thing up. But before we group it up, we want to look to see if there's any greatest common factor. So I look for factors of 30, 24, negative 35, and negative 28, and I don't find anything besides 1. So then I look for anything in the variables. Is there a variable I can plot? Is there a g in every term? There's some g's here and here and here, but there's no g in this final term. So I look for h's. There's h's here, here, and here, but no h's here. So I can't pull out a greatest common factor, so that step doesn't help me. So the next thing I do is, well, actually I was going to start grouping it up, but I want to remind myself, whenever I see these subtractions, I want to change those to an addition by adding the opposite. That's going to make things a little bit easier down the road. So once I've got that all situated, then I want to group the first 2 terms and the second 2 terms. Notice that's a negative now. Okay, and then I want to start factoring out the greatest common factor of each grouping. So in this one, it looks like there's a 6 I can pull out, and also some g's, and it looks like I got 3 g's I can pull out of there. So that leaves me with 5 times g to the 2nd. That'll give me the 5 g's, and 6 times 5 makes 30. And over here I'm going to get 4, and then I don't have any more g's because I got g to the 3rd already, but I've got an h. Okay? So I factored out the greatest common factor of this one. Now I'm going to do the same thing here. I'm going to factor out the greatest common factor, and I notice I have 2 negative numbers, so I'm going to pull out a negative 7. And then I've got some h's in each one, so I'm going to pull out 2 h's, because I got 2 h's here and 3 there, so the biggest number I can pull out is 2. And so then I multiply this out, or factor it out, I'm left with 5, and I got to get some g's here, so g squared. So negative 35, g squared, h squared should match up. And then I'm going to pull out a 4, and h to the 2nd times h would give me h to the 3rd. And then as always, once I've done that, I look to see if there's a greatest common factor of these 2 terms. And sure enough, this is a factor of both terms. So I pull that out as one of my factors, 5g squared plus 4h. And then the other factor is what I'm left with once I factor that out. So now I've got 6g to the 3rd minus 7h to the 2nd, or plus negative 7h to the 2nd. So when you think about it, don't let those variables, all those exponents and stuff confuse you. It's pretty simple. It's the same strategy we used before, just a little bit more complicated, but the math still works.
Oh my God.